So we have LogixPro Simulator open now. We're operating in a Windows 10 environment. It may appear slightly different if you are operating with a different operating system. Now this is a fairly old piece of software. It has a few quirks in it that we need to account for. So the first one we're going to fix is this area up here, this great big white area. You'll see there's 8 buttons, but around the rest of this area there's some information that is missing that is not shown up. The easiest way to make this show up is first to minimize that window, and then we can reopen that window from the toolbar. So I'm just going to minimize that now. So now that I've expanded my window, we can see that there is some other information around these buttons. We're going to require the use of a lot of this information. So it's good to get it up visible now. The second thing I'm going to deal with is if I have a look at a rung. A rung is very much like a circuit using relay logic. We need a power rail and a return rail. We don't have a return rail visible. In fact, the right-hand section of this is completely missing. If I was to try and program there, the program would occur, but it would not display. We want to be able to see everything we're doing. So to make this show up is very simple. If I go over here and I grab this power rail on the ladder 2 window and I drag it across to the right, I can see that the word end is showing up, indicating, in this case, the end of my program, and my return rail is available. So that's the second problem solved. The third one, you don't actually see in this recording. It's a limitation of the software. But down here where my mouse is on your screen, you may see a chap that looks a bit like a wizard. Now, wizards were all the rage 20 years ago. Frankly, they're a pest in this case. We're just going to right-click on them and hide them. Make the wizard go away. Now we're set up to actually start our programming. The first part that we're going to look at here is this window here. This is the simulation window for what we're going to be doing in this lesson. We're just going to use a basic I/O simulation. So if I go up to the top, I can find simulations. I click on that, and I'm going to choose I/O simulator. This will give me my interaction method with my simulator. We're going to use 2 parts of this in this lesson. The first is inputs, and we're going to use some outputs. We're not going to use the BCD simulator, just basic digital inputs and digital outputs. If I first look at input 1, this is slot 1 or card number 1 in my PLC. Card number 1 address 00. By default, there is a switch, just a simple little switch. If I click on it with the left mouse button, I can close that switch. You'll see that the 00 is now backlit with red, indicating that this is true, or in an electronic sense, that current would be flowing through the switch. Left click on it again to open it. If I right click, I can change the style of switch. I have some other options available. The first one is a normally open push button. This is a momentary push button. So if I click and hold it, it would be true. As soon as I release, it has gone back to false again. If I go down to input number 01, I'm going to click it twice, and we have a normally closed momentary push button switch. If I click on it with my left mouse button, I can open that switch. Therefore, it is false. Let go of my mouse button. I have a current path through it, a true. Next one, we're going to click on it 3 times and show a limit switch, which is normally open. Once again, I can manually close it, but as soon as I release, it will open again. Next one down, I'm going to click on 4 times and get my normally closed limit switch. So I have 5 types of input switches available, and we'll just select whichever type is necessary for us to be able to test our program. Sometimes we're going to change the switch style to be able to test it. It's not going to match what we need, but in order to test a rung, I may change the switch style. On the outputs, If I click on the outputs, nothing much is happening. The program is running the outputs and I have no program, so they're not going to turn on. The limitations I have with my outputs is I can just change the color of them. I can have a red one and a green one and a yellow one. Now, of course, they're not on, so they're all black. These are the items that we can work with in the simulator during this lesson. So this is the task we are going to program today. We have a mixer that we've seen before in our previous classes, where we used a relay logic system to control this. We are going to have a manual push button switch as an input, a temperature sensor as an input, a pressure switch as an input, i.e. we can detect that a volume of fluid has been filled enough with this pressure sensor, and the output is a motor which we will turn and operate. This was our relay logic system for controlling this, with the pressure switch and temperature switch could turn on the motor, or the manual push button could turn on the motor. In a PLC, we're going to wire each of those switches in individually to the input module. So we have here pressure coming into input 1 in this example, temperature to input 2, and the manual push button into 3, all individually wired up to the input module. On the output module, we see that we just have the motor wired up here in this example to output number 1. So we're going to create a PLC program to replicate what we saw with the relay logic program. The structure of this ladder diagram looks very similar to what we had initially for our relay logic. We need a pressure switch operated and a temperature switch operated in order to start the motor coil, or the manual push button pressed to start the motor coil. So let's go ahead and have a look at actually programming this in our simulator. So back to our simulator to create this program. This ladder 2 window, this is our area we're going to create our program. What we're interested in using are these symbols up here, these user symbols, to create our program. We're going to be able to add a rung. We're going to create branch instructions. We're going to use the examine if closed. Looks very similar to the normally open contact in a relay logic. We pose this as a question when we're doing logic. Examine if it's closed. Is it closed, true or false? The examine if open symbol, which looks very similar to the normally closed contacts in our relay. And then we have an output energize. This operates very similar to the relay coil that we had in our relay logic. Now what I find easiest to do is to simply build the structure of each individual rung first, and then I start populating the symbols into the rung, and then I start assigning addresses and descriptions to those individual items within the rung. So the first thing we're going to do is press for new rung. As you can see, 00 now no longer has the end. This line that was there got bumped down. We always need an end in this simulation, as we do in a lot of real PLCs. So I've created a rung that I'm now going to edit. Remember from the previous little clip, we needed a branch in it. So I'm going to add a branch, and oops, unfortunately it added a whole rung. This is easy to solve. If I click on the rung, previous rung, that I really don't need anymore, if I right click on it, I can cut that rung, delete that rung, a little bit of a different terminology. Now I'm back to my rung, and it has a branch in it. I want to populate this branch. Remember, the first thing I wanted to do was have a pressure switch and examine if closed. So if I click on the examine if closed symbol and I hold down, this is with my left mouse button, I drag it over towards my programming window, and if there's a valid place to put it, the little box will change to green. I want this to be one of the first things in my program, so I'm going to drag it over here and release my left mouse button. I also needed another one of those for my temperature switch right beside it, so I'm going to drag another one in to this valid location, Now I have two examine if closed. I also wanted another examine if closed for my manual push button. So let's go ahead and push that in. Down on the branch. The last thing I need to complete this would be an output energize. So I'm going to click on the output energize and I'm going to drag it. If I drag it all over to the right, see nothing valid pops up. The valid position is at the end of the rung, but it is showing that I should really come over here to where these little boxes are. So if I click here and let it go, you'll see it actually populates all the way over on the right where it should have populated. Now I have the structure of my rung, very similar to what we had with the relay logic. So let's go ahead and start putting the addresses in on these symbols. I'm going to click here on this first one, on that question mark there. Just double click it with the left mouse button. Now this is an input device, so an I for input, and then a colon to delimitate. The input we're going to use is in card number 1 or slot number 1, and then there is a slash, and the input number on that card we're going to use is number 1, just to keep it in common with what we had in our previous slides. Then press enter. So we have now that first one addressed. If I go down to the symbol and I right click, it's very poorly described for modern terminology, but edit a symbol. This allows me to write in a description that the human being will use. The PLC doesn't care about this, but it just makes our lives a bit easier to describe things. And this was going to be our pressure switch. So I'm just going to type in pressure switch. And then enter. Not every PLC is going to allow this. Some of them are limited to 8 characters. A lot of people just want to have 3 characters, maybe PS1 or something like that. Some PLCs, the description is above and the address or tag is below. There's a lot of variation out there. For our simulator, this is what we want to do. And I'm just going to carry on and I'm going to fill in the rest of the addresses and descriptions. Once again, I am going to left click twice on the question mark, replace it with my I for input, my colon. It's going to card number 1, slash, it's going to input number 2 on that card. Then I'm going to right click on the symbol, choose edit symbol, and I'm going to type in the temperature switch. Once again, this time I'm going to do it a little differently. The simulator is not very fussy about capitals and things like that. So if I push just a lowercase I, it's fine with that. If I used a semicolon instead of a colon, it's fine with that. It does absolutely need to know which card it is. It does need to know the slash, and in this case, input number 3. And you will see it's going to auto-correct. Go and edit my symbol. This time is going to be a manual switch. Don't forget my output. I need to adjust this as well. Once again, oh, I did that wrong. I need to double click with the left mouse button in this case to change this. O for output, colon, or semicolon. Output is in card number 2, and we are going to use output number 1. And now I can go through and right click on the symbol, edit my symbol, and it is the mixer motor. Oh, bad typing there, Chris. So now I have built my first rung. Let's add a description to this rung. We usually like to know what it's doing, make it human readable. Why is it relevant to our process? If I go over the 00 and right click, I'm going to just edit a rung comment. Now usually in a large program, I'm going to have an intelligent comment, very small program here, but I'm just going to type in a small comment. This was our mixer process control problem. And leave it at that. So now I have a comment for that rung. It's our mixer process control problem that we saw in relay logic, and we are reusing again today. Thinking back to our circuit that we have for our mixer process problem, pressure switch was a normally open pressure switch. We don't have a normally open pressure switch. So for the purposes of this simulation, I'm just going to change back to our default switch, which I can open and close and leave alone in those positions. So we'll maintain the temperature switch, the same thing. I don't have a normally open temperature switch, but I want some sort of switch I can maintain. So I'm just going to paint input number 2 back to the default switch. The manual switch was a push button switch, a momentary push button switch that was normally open. We do have one of those, so I'm just going to change that symbol to my normally open manual push button switch that is momentary. So now I have 3 suitable switches for my output, and I'll be using, the inputs, and I'll be using output 1. Now then, the next thing we have to do is to download this. So this simulation, we've created a program on a PC that is part of the simulation. We have a simulated PLC that we need to simulate the downloading of our program into that simulated PLC, much like we do in the real world. So that's our next step. We're going to download that program into the PLC. We're going to switch that PLC to the run mode, and we'll run the program and interact with that program. So the first step, we're going to change this from offline. This is the only piece we're going to use in this area today. We're going to click on the arrow beside the offline, and from the drop-down menu, select Go Online. You'll notice the change that occurred over here. We lost those 8 buttons that allowed us to do some programming. We're now simulating this from the perspective of the PLC. We're looking at it from the PLC. From the PLC's perspective, though, we don't have this program. It only exists in our computer. So let's download, press download, download that program from the computer to the PLC. Nothing really indicates this has been successful except for the fact there were no errors. Most simulators and PLCs, we're going to see a change here when we move to the run mode. We're going to see these bars change color. Not with this simulator. It's just going to change to the run mode, and we've got some inputs and outputs we're reading. Simulator is showing a scan rate. I like to slow the scan rate all the way down to the minimum. The reason for that is this is a very old simulation. PLCs, computers, were considerably slower 20 years ago. The software operates by looking at the tick rate or the processor speed of the processor of the computer. They're a lot faster now than they were 20 years ago. The simulations don't work very well at full speed anymore. So that's why I like to slow it all the way down to the slowest speed. It's just a little bit more reliable that way. We're in run mode, nothing really to indicate it, but let's go ahead and test our program. So what are my expectations? My expectations are I'm going to have to adjust my switches. If the statement, which is examine if closed, is false, that would make the next step irrelevant Boolean logic wise, because I have a pressure switch and a temperature switch or a manual switch controlling my output, the motor. A false, examine if closed, that the answer would be false. Examine if closed, the answer would be false. Or a manual switch, we can see once again the answer would be false, the output would be false. So if this became true, I would have a true and a false, or a false. The answer would still be a false. Let's go ahead and test that by closing the switch. I'm going to left click on this switch. Remember, it's maintained, so I can left click and leave it alone. We'll notice that the 01, which is the equivalent of an LED on the input card, is lit, i.e. a true. There is power coming in to my PLC from this input device. If I go over and look at my program, we can see the address is now highlighted in yellow. This indicates that the statement is true. Examine if closed. Is the switch closed? Yes, it is. That's true. So that's why this is now true, working as per expectation. Still no motor wrong. From a Boolean logic perspective, I don't have a true. I've got a true, correction, a false, and a true, or a false. I will still have a false. So I need to make this pressure switch and temperature switch turn on in order to get the motor to turn on. So it says Boolean logic. So let's turn that switch on, and I can see a true and a true gave me a true. The output 01 has now lit up. It's gone from black to green because we pre-selected that the LED for that output would have been green. So I have an indication now, yes, the output is true, the motor is on. Let's go ahead and turn those off again to be able to test my last input device, which was this momentary manual override push button. If I click and hold it, I can see my manual switch address, input 13, has got a yellow background, and I can see it has turned on the motor. I can see from the input output card that input 103 is red, true. Output 21 is red, also true. Release it and it would turn off. So it looks like I've successfully built my code, my piece of control software, and in the simulator, and that everything there is working correctly. So let's now go back to an offline mode so we can practice our next piece of our tutorial today. So next we want to modify our previous program. From the relay logic, we had to rewire our manual push button to be in parallel with just the pressure switch, so that whichever one was active, the temperature switch had to be used in order to start the motor coil. We want to do this with our PLC program. It's a lot simpler with the PLC program than in the relay logic world, where I would have to disconnect the wire, reroute it to some point, maybe even install some additional hardware to be able to accommodate that extra wire. It would take a little bit of time, money, maybe a whole new piece of wire. So let's go ahead and modify our PLC simulator program. So here we are back with our LogixPro simulator. If I want to modify the program, I'm not actually going to grab the wire in this case. I am going to click on my statement with my left mouse button, and I'm going to drag it to a new location. So I'm going to drag temperature switch outside the OR loop to this location here, release my mouse button. I have now reprogrammed that line of code. Simple as that. Let's go online, download it, and test it. So we're going to go online. I'm going to download the program. I'm going to place it in run mode. Let's go ahead and test this. I am going to press this temperature switch down first, and I am going to then push the manual switch. And I can see the manual switch and the temperature switch are true, therefore the motor is true. Let's turn off the temperature switch, press just the manual switch. In the previous version of this program, that would have turned on the motor. Because my manual switch or my pressure switch must be true, and the temperature switch must be true to turn on the motor, we can see that the motor did not turn on. So very easy to modify a piece of PLC code compared to a hardwired relay logic. It's one of the huge benefits of PLCs. The total time to make a system is less. The flexibility to change that system is far more than with a solid relay logic system. So that brings an end to this tutorial.